Good morning, students. We have not met for a long time. Saturday, Sunday, Monday, and Tuesday. So 4 days we have taken a long leave. We have not met. Hope you have not lost connection with me. So yeah, before we proceed further with the lesson which I was teaching, I would just like to recall whatever we had already learned. So we were discussing about metals and non-metals. Just because we are meeting after 4 days, I just want to refresh everything whatever is there in your brain, so that you will have a better understanding of the further topics. So we had discussed about the session etiquettes, which I had already told you. Listen carefully and observe the presentation when you're listening. Don't keep writing anything, and don't get distracted when you're listening to my video. And be placed in a quiet place, so that you will be away from distractions, and you can ask any number of questions in the group, and I will be able to answer all your questions. And you're free to ask questions via WhatsApp group. So yes, you may post your questions, and then I will answer the questions when I find time. Okay. And also I had told you that I will be asking a number of questions, which I actually am not doing, right? So don't start cursing me, sir. You asked so many questions, and now you're telling no, you're not asking questions at all. So then we had discussed about the physical properties of metals and non-metals. Metals are hard, and they cannot be broken easily. Non-metals are soft and brittle. Metals have a lustrous surface. Non-metals do not have a lustrous surface. They have a dull surface. Metals are malleable, and that means they can be drawn into sheets. And non-metals are not malleable. They cannot be drawn into sheets. They cannot be beaten into sheets, I'm sorry. Metals are ductile, that is, they can be drawn into wires, thin wires. Non-metals are not ductile. That means they cannot be drawn into thin wires because they are brittle. They can be broken easily. And metals are good conductors of heat and electricity. Non-metals are bad conductors of heat and electricity. Metals have a characteristic sound. They give a characteristic sound, that is why they are called as sonorous. They have give a ringing sound. And non-metals are not sonorous. Examples for metals are calcium, magnesium, iron, copper, aluminium. These are only a few examples, and there is a huge list of metals in our periodic table. And non-metals, again, sulfur, carbon, oxygen, and phosphorus. Okay. And then we had discussed about a few metals, which are metals and non-metals, which are unique. So the soft metals are sodium and potassium. Liquid metal is mercury. Liquid non-metal is bromine. Lustrous non-metal is iodine. Non-metal that conduct electricity is graphite. So what we will be discussing today, an empty slide. No, I just want to use my presentation just like a whiteboard or a blackboard, whatever you feel. Now, just because this is white, I will say it is a whiteboard. Okay, today we will be discussing about chemical properties of metals and non-metals. So we will be discussing about chemical properties of metals and non-metals. So all these days we were discussing only physical properties. Physical properties is how they appear, how they look. How can we identify metal and non-metal just by seeing or just by touching and feeling? Correct. So today onwards, in another few classes, we will be winding up the chapter. So for the rest of the classes, we will be studying about the chemical properties of metals. So chemical property is, there is a difference between physical reaction and chemical reaction, if you people have not forgotten. Physical reaction is a reaction in which the products can be brought back to the original state. For example, crushing of paper. If I'm crushing a piece of paper, say I will crush this piece of paper, I can bring back this paper to our original shape by removing the external forces. This is a physical reaction. But in case of chemical reaction, if I will burn this paper, I cannot obtain the paper back. So that is a chemical reaction. Another example I can give you is dissolving salt in water. Salt in water, I can get back the salt by removing all water. So that is a physical reaction. And chemical reaction is dissolving sugar in water. If I will dissolve sugar in water, I can get back. Can I get back the same sugar again? If you have really experimented, you will say no. Correct. So we will be discussing about chemical reaction of sorry, chemical properties of metals and non-metals. That is, how do metals and non-metals react with various substances in the environment. So first thing is, so reaction with oxygen. We will be discussing about the reaction of metals and non-metals with oxygen. How do metals react with oxygen and how do non-metals react with oxygen? That is what we are going to discuss. So first is metals. So you had conducted an experiment, and I mean you had an activity in the previous year, that is in 7th standard, burning of magnesium ribbon. Do you remember? So when a magnesium ribbon is burned, what happens there? So burning is what? Combustion is what? Combining with oxygen. Burning is combining with oxygen. So magnesium will burn with oxygen. It will combine with oxygen. And what is given there? The product is magnesium oxide. Correct? This is one example. Another example, you all know how iron will rust, how iron will corrode, right? So when iron is exposed to the moisture in the air and oxygen in the air, it reacts with oxygen to form iron oxide, that is called as rust, the brown colored thing what we observe on iron nails or iron substances which are left over exposed to air for a longer time. So that is iron oxide. We call it as ferric oxide or iron oxide, right? So what happens to metals when they react with oxygen? It is as simple as it is. So I can write a generalized statement like metal when reacts with oxygen, it will give a metal oxide. Okay, iron reacting with oxygen will give iron oxide, copper reacting with oxygen will give copper oxide, and magnesium reacting with oxygen will give magnesium oxide, and so on. So will copper actually rust? I want you to give me the answer. And in the next video I'll give you the answer if you don't know the answer. Okay, so metals react with oxygen to form metal oxides, and yes, what is the nature of this metal oxide? Are they acidic or basic, or how are they? So to check this, what do? We use a litmus paper, correct? So for example, I will take the first one, magnesium and oxygen. So when magnesium is burnt in the air, that it reacts with oxygen to form magnesium oxide. Magnesium oxide is a white colored powder, just like ash. Okay, so if I will dissolve this magnesium oxide in water, and I will take a blue litmus paper and dip in the magnesium oxide solution, which is dissolved in water, do I observe any color change? Right now, I don't have a litmus paper with me to show, but I'm just explaining you, assuming that you people have seen litmus paper already. Okay, when I dip the litmus paper, blue litmus paper in the magnesium oxide solution, there is no color change. That means if blue litmus paper is not changing its color, that means magnesium oxide is not acidic. Correct. Similarly, I will take a red litmus paper and dip in this solution of magnesium oxide dissolved in water. So the red litmus paper will turn into blue color. So the red litmus will turn blue. So what does this indicate? All the magnesium oxide is a basic oxide. Similarly, if I will do the test with all other metallic oxides are basic in nature. Okay. So what is the nature of metallic oxides? They are basic. Metallic oxides are basic. That is why, see, all the metal oxides are used in the formation of, production of bases. You have learned acids and bases in the previous class, previous year, correct? So if I will ask you to give me some examples of acids, you will say sulfuric acid, nitric acid, hydrochloric acid, and all that. And if I will ask you to give the examples of bases, you will say sodium hydroxide, potassium hydroxide, calcium hydroxide, magnesium hydroxide. See, everywhere there is a metal. Sodium hydroxide, sodium is a metal. Potassium hydroxide, potassium is a metal. Calcium hydroxide, calcium is a metal. correct? Magnesium hydroxide, magnesium is a metal. So all the metallic oxides are basic in nature. That is why they are used in production of bases. I mean, synthesis of bases. Coming to non-metals. So what happens? As I say, for example, I will take sulfur as a non-metal, right? So I will take sulfur. If I will burn sulfur in oxygen, I mean, if I will burn sulfur, what happens? I will get a gas. If sulfur is burnt, then I will get a gas. What gas is that? Okay, it should be oxide of sulfur. Okay, the gas is a oxide of sulfur. I cannot say whether it is sulfur dioxide or sulfur oxide. So it is an oxide of sulfur. Again, there is a spelling mistake, my bad. Okay, so this is a gas. What I will do, I will collect all this gas into a conical flask or a jar. Okay, and somehow I will use a bent tube, or I will use something, some funnel or something like that, to uh, collect all this hydrogen, I mean, the oxide of sulfur into a jar, and I will mix it with water. A little bit of water I'll add, because I have to test it for its nature, correct? So when I will add water to it, and I will use a red litmus paper. So what happens to this red litmus paper? Will it change its color? No, the red litmus paper will not show any change in color. That means this non-metallic oxides are not basic in nature. So if I will use a blue litmus paper, so the blue litmus paper turns red. Okay, so this indicates that non-metallic oxides are acidic in nature, correct? So non-metallic oxides are acidic in nature. That is why the blue litmus paper is turning into red color. So because these non-metallic oxides are acidic in nature, they are used in the preparation of acids. Am I clear with that? So sulfuric acid is there, sulfurous acid is there. So what is the difference between sulfurous acid and sulfuric acid? Find out. This is another question for you. The difference between sulfurous acid and sulfuric acid. So just to summarize, this is the reaction of metals and non-metals with oxygen. Metals react with oxygen to give metallic oxides. These metallic oxides are basic in nature. That is why they are used in preparation of bases. And non-metallic oxides are acidic in nature. They are used in preparation of acids. So wait for the next video. And in the next video, I'll be answering the questions which I have asked you now.